All right, here we go with the particle problem. It's going to be a very popular problem because it's able to test your understanding of the relationship between position, velocity, and acceleration, and also the difference between average velocity and instantaneous velocity. So there's a lot of things happening all within this one problem. So first of all, we have a function for its position along the x-axis after t seconds. The first part says, where does it start? Well, that's going to happen when the time is at 0 seconds. So all we have to do is plug it in. 0 cubed minus 3 times 0 is going to be 0. So it's going to start at the origin. In part B, it asks for the average velocity over the first 4 seconds. So all we need to know is distance over time. How did its position change from where it started to the 4th second? So we also have to find out what x of 4 is. Plugging that in, we'll have 4 cubed minus 3 times 4. So that's 64 minus 12 is 52. 52 is not the average velocity, that's just its position at the end of 4 seconds. So in order to find the average velocity, we're going to take its position at the end minus its position at the beginning, and then see how that relates to the time at the end minus the time at the beginning. So x of 4 was 52. The original starting spot was the origin, over 4 minus 0. That's 52 over 4, which is 13. Paying attention to the units, in the numerator, we had the position at x of 4 and the position on the x-axis when time was 0. So on the x-axis, those units are just called units. But our time units in the denominator goes from 0 to 4 seconds. That means when we simplify this down, the average velocity is going to be 13 units per second. So average velocity is just a rate of change in position over time. Instantaneous velocity, on the other hand, is a derivative. And so to find the velocity function, we have to take the derivative of the position function. In this case, the derivative of t cubed is 3t squared, and the derivative of 3t is 3. Now we can calculate that instantaneous velocity at t equals 4 by just plugging in 4. 3t squared, that'd be 3 times 4 squared minus 3. 3 times 16 is 48. 48 minus 3 is 45. And because we're talking about velocity again, our units are the same as they were in the last part, and that is units per second. In part D, it asks, when does this particle stop? Well, if you think about when you are stopped, what's your velocity? It's 0. You don't have any speed when you're stopped. So we're going to take the velocity function, 3t squared minus 3, and set it equal to 0. Solving it real quickly, we add 3 and divide by 3, we see t squared is 1, so it stops at positive and negative 1. As far as time goes, those units are going to be plus or minus 1 second. There's a few pieces of information that we already know. For instance, we already found out that the particle starts at the origin, and we also know that after 4 seconds, it's at 52 units. We know that 1 second is important because that is when the particle stops. The thing that we didn't find out is where it stops. So we can quickly calculate what x of 1 is by plugging it into our position function, and we'll have 1 cubed minus 3 times 1, that's 1 minus 3, is negative 2. We do also have a velocity function. Real quickly, we found that out to be 3t squared minus 3. So let's take a second and think about what's happening. First of all, we have the x-axis that this particle is moving back and forth on. Initially, it starts at the origin. Then, it's going to take 1 second to travel backwards to negative 2. That's where it's going to stop, turn around, and go all the way over to the right, where after 4 seconds, it ends at 52 units to the right of the origin. It's real helpful to kind of draw this out a little bit as you try to put it into words. Now to do part F, it says, so the particle starts at the origin, like we said. Then it moves to the left, over to -2. It did that for 1 second, stopping at -2. Next, it turns around and moves to the right before ending at 52. Overall, the particle traveled how many units? Well, we think about this. First, it traveled 2 units to the left before traveling 2 units to the right to get back to the origin, and then going another 52 units before finishing up. So that looks like a total of 56 units. But it only ended up 52 units to the right of where it started. Almost to the end. By now we have a function for the position of the particle, and we have a function for the velocity of the particle. Now to find the acceleration of the particle, all we have to do is take the derivative of the velocity. So acceleration is the derivative of the velocity. We go back to that velocity function, and the derivative here would be 6t minus 0. Finding the acceleration at any given time point, in this case at 4 seconds, all we have to do is plug in 4, and that'll give us 24. Now, the units for position are just going to be units. The units for velocity are going to be units per second, and the units for acceleration are going to be units per second squared.